Hello everybody, my name is Ronak Adhikari. I am a grade 12 student studying in DAV College, and today we're going to talk about trigonometry. So what is trigonometry? To put it simply, trigonometry is a branch of mathematics that deals with sides and angles of a right angle triangle and the calculations based on them. Today in this lecture we're going to talk about right angle triangles, trigonometric ratios, and the relationship between trigonometric ratios. Right angled triangle. A triangle having one angle 90 degree is called a right angled triangle. In the given figure we have a triangle A, B, C, and the triangle is right angled at C. So we can write that angle ACB is equals to 90 degrees. A right angled triangle is also called a orthogonal triangle. In a right angle triangle, the sum of two acute angles is also equals to 90 degrees. So in the given figure, the sum of two angles CAB and ABC is equals to 90 degree. Now, since we know the value of all the three angles of a triangle, and if we add them, the sum of three angles of a triangle becomes 180 degree. Now we're going to talk about perpendicular base and hypotenuse of a right angle triangle. Let us suppose a triangle ABC which is right angled at B and theta be its angle of reference. So what is angle of reference? The angle between two terminal arms of a triangle is called angle of reference. In the triangle ABC we can see that AC and BC are the two terminal arms of a triangle and theta is the angle between them. So theta is the angle of reference. Now the side which is exactly opposite to the angle of reference is called perpendicular, and in the figure we can see that side AB is exactly opposite to the angle of reference. So AB is the perpendicular of the right angle triangle, and the side which shares common vertex or is adjacent with the angle of reference is called base. So in the figure we can see that the angle of reference and side BC share common vertex, so BC is the base of the right angle triangle. And finally, the side which is opposite to the right angle of a triangle is called the hypotenuse. And in the figure we can see that side AC is exactly opposite to the right angle of this triangle, so AC is the hypotenuse of the right angled triangle. Trigonometric ratios. So what are trigonometric ratios? Trigonometric ratios are the ratios between edges of a right angled triangle. Now let us draw a right angled triangle and name it x, y, and z. The triangle is right angled at y and A is its angle of reference. So the side xy is perpendicular, yz is base, and xz is hypotenuse. Now the relationship between perpendicular and base, or base and hypotenuse, or hypotenuse and perpendicular, are called trigonometric ratios. There are 6 trigonometric ratios. They are sine, cos, tan, cosec, sec, and cot. Now sine A is given by perpendicular by hypotenuse, cos A is given by base by hypotenuse, tan A is given by perpendicular by base, cosec A is given by hypotenuse by perpendicular, sec A is given by hypotenuse by base, and cot A is given by base by perpendicular. If we observe these 6 ratios closely, we can see that cosec, sec, and cot are just reciprocal of sine, cos, and tan. So sine A is given by perpendicular by hypotenuse, and if we reciprocal perpendicular by hypotenuse, we get hypotenuse by perpendicular, which is cosec A. Now we're going to talk about relationship among trigonometric ratios. From the last slide we know these 6 following trigonometric ratios. Now we're going to use them to find the relationship among them. For the first relation we're going to take sine A. So sine A is given by P by H, and we can also write P by H as 1 upon H by P, and H by P is given by cosec A, so sine A can also be written as 1 by cosec A, which verifies the first relation. Similarly, we will use cos A for the second relation, which is cos A equals to b by h, and also we can write b by h as 1 upon h by b. So h by b is given by sec a, so cos a can be written as 1 by sec a, so which verifies the second relation. Now we're going to skip the third relation for now, and we're going to focus on fourth relation, which is tan is equal to sine a by cos a. For this we're going to take tan a equals to p by b, and we're going to divide both numerator and denominator by h, and p by h is given by sine a and b by h is given by cos a, so we can write tan a as sine a by cos a, which verifies the fourth relation. Similarly, we're going to use cot a for the fifth relation, which is cot a equals to b upon p, and we're going to divide numerator and denominator both by h, so b upon h and p upon h, and b upon h is given by cos a and p upon h is given by sine a, so cot a becomes cos a by sine a, which verifies the fifth relation. Now from relation 4 and 5 we know that tan a equals to sine a by cos a and cot a equals to cos a by sine a. So if we put value of tan a and cot a in relation 3, we'll get value 1. So tan a equals to sine a by cos a and cot a equals to cos a by sine a, and we'll cut sine a, cos a, which gives us value 1, which verifies the third relation. And now for the final topic of the lecture, we're going to talk about relationship among trigonometric ratios based on their ratios and Pythagorean relation. We all know the Pythagorean relation, h is equal to p square plus p square. Now we are going to use this relation to derive the relationship between trigonometric ratios. To derive the first ratio, we will divide both of the sides of this relation by h square, so we get 1 equals to p square by h square plus b square by h square, and we know that p by h is given by sine a and b by h equals to given by cos a, which gives us the first relation, sine square a plus cos square a equals to 1. And now to derive the second relation, we will divide both sides by b square, b square, and we will get h square by b square minus p square by b square equals to 1. And we know that h by b is given by sec a and p by b is given by tan a, so we get the second relation, which is sec square a minus tan square a equals to 1, and we can rearrange this relation into 1 plus tan square a equals to sec square a. And now for the third relation, we'll divide both sides by p square, so p square, so we will get h square by p square minus p square by p square equals to 1, and we know that h by p is equal to cosec a and b by p equals to cot a, which gives us the third relation, cosec square a minus cot a equals to 1, and we can rearrange the relation into 1 plus cot square a equals to cosec square a.